This is Algebra 2, Unit 9, Lesson 5, and in this lesson we're going to talk about finding all vertical and horizontal asymptotes and holes of a graph. We're not going to concentrate on graphing yet. For this section, we're going to talk about some special cases dealing with rational expressions. In this chapter so far, we've taken rational expressions and we've done the 4 math operations with those. And we've talked about how to simplify rational expressions by factoring. And all of those methods are going to be used in some form when you're dealing with graphing these rational expressions. And the main thing you need to understand is that anywhere you have a graph or an equation of a graph and the denominator could possibly be equal to 0, those are going to be considered values in the graph that have special things happening. You're either going to have a hole at those places or you're going to have an asymptote at those places. And depending on which one it is, will dictate how you graph those things. And so basically we need to talk about first what an excluded value is and how to determine whether excluded values are holes or asymptotes. And then we'll talk about horizontal asymptotes. Those are kind of separate altogether. But with vertical asymptotes, that's what we're going to talk about first. You can only have a vertical asymptote when the denominator of a function is equal to 0. But if the denominator of the fraction or rational expression can be canceled out because of some other factors, then that becomes a hole instead of an asymptote. So you have to be able to distinguish between the two. So I've got a couple examples here that we're going to look at, and we're going to talk about the difference between whether you have a hole or an asymptote first. And we're talking about vertical asymptotes when you're talking about the denominator. So the first thing I'm going to do with this, if my directions were to find all horizontal and vertical asymptotes and holes, the first thing I'm going to do with this is I'm going to factor it and see if anything will cancel out. Once I see if something can cancel out, I can determine whether I have vertical asymptotes or holes. So when I factor this, the top factors, that's the difference of squares. That's x plus 3 times x minus 3. And the bottom is x plus 3. And notice here, the x plus 3 will cancel out. Okay, so since that canceled out, the x plus 3 is still going to be undefined when we set the denominator equal to 0. So if we set that denominator, x plus 3 equals 0, then at x equals negative 3, we have something special happening. The function is undefined at x equals negative 3 because you can't have division by 0. X equals negative 3 is also called an excluded value. That's another term that you might hear and be asked to find the excluded values. Okay, so x equals negative 3 is an excluded value. It makes the function undefined, but since the factor associated with x equals negative 3 canceled out, this is not going to be an asymptote, it's going to be a hole. So we have a hole in this graph at x equals negative 3 because the factor associated with it canceled out with a factor on the top. Okay, now we'll come back to this one for horizontal asymptotes in just a few minutes. For the second one, the first thing again that I'm going to do is I'm going to factor the top and the bottom. On the top are the factors of 20 that subtract to give me 1, 4, and 5. So I'm going to have an x with a 4 and an x with a 5. The 5 gets the plus, they have different signs. And then on the bottom, that's difference of squares. So we've got x plus 4 times x minus 4. Now, we have two excluded values here. When we set these equal to 0, we would have x equals negative 4 and x equals 4. Those two have something special happening. Those are our excluded values. Okay, but what we need to know is whether these excluded values are going to be holes or vertical asymptotes. In order to figure that out, I need to investigate what will cancel and what will not. If you look up here, the x minus 4 cancels. Anything that cancels becomes a hole. So since the x minus 4 canceled, if I set x minus 4, the one that canceled, equal to 0, I will get x equals 4. So I have a hole at x equals 4. X plus 4 does not cancel. Since x plus 4 doesn't cancel, if I set that equal to 0, I'll get x equals -4, and that is the equation for my vertical asymptote. And what that means is a vertical asymptote is a line that the graph will approach but doesn't very often cross it. Now, there's nothing that says it can't cross an asymptote. It's possible for a line to cross an asymptote, but at some point on the graph, your line has to approach that asymptote. Now, for vertical asymptotes, they're not going to be crossed, but sometimes horizontal asymptotes can be crossed. But an asymptote is just a line, an invisible or an imaginary line within your graph that the graph will approach somewhere on the graph. Okay, so that's how we distinguish between holes and asymptotes. It's a hole if the factor that gave you that excluded value cancels out. It's a vertical asymptote if the factor of the excluded value does not cancel out. The next thing we need to talk about are horizontal asymptotes. And a horizontal asymptote is going to be a horizontal line that your graph at some point approaches. In a horizontal asymptote, there are 3 things you're going to have to memorize. There's no way around it. You're just going to have to memorize when you have horizontal asymptotes. And these are the 3 things. If the degree of the top expression is equal to the degree of the bottom expression, then your horizontal asymptote is the equation y equals, and it's the ratio of the leading coefficients. If the degree of the top is less than the degree of the bottom, then your horizontal asymptote is at y equals 0. And if the degree of the top is greater than the degree of the bottom, then there are no horizontal asymptotes. So I want you to pause the video, go ahead and copy these down in your notes, and then we'll talk about that in some examples. So I've got up here the same examples that we did vertical asymptotes and holes with. So I want to look at these same examples. I'm looking at the first one. The degree of the top is 2. The degree of the bottom is understood to be a 1. So the degree of the top is greater than the degree of the bottom. So for that one, if the top degree is larger than the bottom degree, there are no horizontal asymptotes. So no horizontal asymptotes, okay? If the degree of the top is the same as the degree of the bottom, then for your horizontal asymptotes, it's going to be y equals, because remember, a horizontal line is of the equation y equals a number, okay? So you have to have the y equals to signify the horizontal asymptote. Just like for a vertical asymptote, you have to have x equals, because if x equals a number is a vertical line, y equals a number is a horizontal line, okay? So with this one, since the degrees are both 2, those degrees are the same. So the degrees are equal. The top and bottom are equal. So my ratio of the leading coefficients, now my leading coefficients on top is a 1. The leading coefficient on the bottom is a 1. So the leading coefficient ratio is 1 over 1. So y equals 1 would be the horizontal asymptote for that equation. Okay. What if I had an example where the top degree was less than the bottom? So like maybe something like this, f of x equals x plus 2 over x squared minus 9. Well, in that one, the degree of the top is 1, the degree of the bottom is 2, so the degree of the top is less than the degree of the bottom, so you're going to have a horizontal asymptote at y equals 0. Now, if you think about that equation, y equals 0, isn't that going to represent the x-axis? The equation of the x-axis is y equals 0. So if the degree of the top is less than the degree of the bottom, your x-axis will be an asymptote, a horizontal asymptote. And that's something that the line will eventually approach. So here I have 2 different polynomials. I've got f of x equals 2x squared minus 50 over x squared plus 5x. And here I've got y equals 6 over x plus 2. It doesn't matter whether they use f of x or y. We know that f of x and y are the same thing. But normally when they ask you to find horizontal asymptotes or holes, or vertical asymptotes, they're either going to have the function equal to f of x or y. The first thing I'm going to do, or the first thing I think that is the easiest thing to do, is to find the horizontal asymptotes, because you're going to look at the original form of the equation to find those. So looking at this, I'm going to decide whether this thing has any horizontal asymptotes. And to do that, I look at the degrees. The degree of the top is x squared, the degree of the bottom is x squared, so they have the same degree. So my horizontal asymptote is going to be y equals the ratio of the leading coefficients. Well, the leading coefficient here is a 2, the leading coefficient here is 1. So it's going to be y equals 2 over 1, which is 2. So at y equals 2, I have a horizontal asymptote. To find my vertical asymptote and holes, I'm going to factor this thing. So I can bring out a 2. When I do that, I have x squared minus 25. And I can bring out an x on the bottom, and that gives me x plus 5. And then hopefully you see that x squared minus 25 is difference of squares. So I'm just going to factor that as difference of squares. X plus 5 times x minus 5. Then, if something cancels out, I have a hole at that spot. If you notice here, x plus 5 cancels out. So since x plus 5 canceled out, that means I have a hole at the x value that I would get when I set that equal to 0. So x plus 5 equals 0 when x equals negative 5. So I have a hole at x equals negative 5. And then the other thing that didn't cancel out from the bottom was the x. And if I set that equal to 0, I have x equals 0. That does not cancel out. So that means I have a vertical asymptote at x equals 0. Now, if you think about that, isn't x equals 0 the y-axis on your coordinate system? Okay, so if I were to try to graph this thing, basically what I need to understand is on my graph, my x equals 0 line is this line right here. That will be an asymptote. So I'm going to draw that dotted to signify that it's an asymptote. And then my y equals 2 line is also going to be an asymptote. And I know that my graph is going to be in 2 of these sections, maybe here and here, it could be here and here. I'd have to do a little more investigating to figure out where it was going to be, but we're going to graph in another section, not this section. So right now, all we're going to do is find the horizontal asymptotes, holes, and vertical asymptotes. We will do the graphs a little bit later, and we're going to utilize Desmos to do a lot of that. But you have to be able to find vertical asymptotes, horizontal asymptotes, and holes by hand, because Desmos won't do all of that for you. It will graph these as imaginary lines. It will not put them on the graph for you. So you have to understand where they are. In the next one, y equals 6 over x plus 2. The first thing I always do is find my horizontal asymptotes. Here, the degree of the top is 0. The degree of the bottom is 1. So the degree of the top is less than the bottom. So that means that I'm going to have a horizontal asymptote at y equals 0. If I try to factor, nothing will factor. So that means nothing will cancel out there. So since nothing cancels, I have no holes. And then if I set the denominator equal to 0, I have x equals negative 2. And since that does not cancel, that would be my vertical asymptote. So I had a horizontal asymptote at y equals 0, a vertical asymptote at x equals negative 2, and no holes. So here are 3 more examples. Go ahead and try to find your horizontal asymptotes, vertical asymptotes, and holes. So here are 2 more examples. Go ahead and pause the video, see if you can work through these on your own. Find the horizontal asymptotes, vertical asymptotes, and any holes that may be in the graph. So here are the answers to these 2 equations. In the first one, I'm going to look for horizontal asymptotes first. Notice here they have the same degree. So my horizontal asymptote is going to be the ratio of the leading coefficient. So it's y equals 4 over 2, and 4 over 2 is 2. So y equals 2 is my horizontal asymptote. The next thing I did was I factored both of those. On the top, a 2 came out, leaving me with 2x squared plus 5x plus 2, and that factored to 2x plus 1 and x plus 2. On the bottom, a 2 came out, leaving me with x squared minus x minus 2, and then that factored to x minus 2 and x plus 1. So it all factored nicely, but if you look at this, there are no factors that will cancel out. And that happens sometimes. When that happens, you just end up with 2 vertical asymptotes instead of 1. And that's perfectly fine. You're going to have a lot of different graphs that have 2 different vertical asymptotes. So my vertical asymptotes here, since none of these canceled, are x equals 2 and x equals -1. And it has no holes because nothing canceled out. You can only have a hole if something on the denominator cancels with something in the numerator. In the next one, if I factor these, I end up with x plus 5. On top, it didn't factor, and on the bottom, I have 2x minus 1 times x plus 5. And then the x plus 5s did cancel in that case. So my horizontal asymptote, notice the degree of the top is less than the degree of the bottom, so that automatically means we have a horizontal asymptote of y equals 0. And then my vertical asymptote would be what I get when I set the factor that did not cancel out of the bottom equal to 0. When I set that equal to 0, I get x equals 1/2. So my vertical asymptote is at x equals 1/2. And again, it's fine to have an asymptote that's a fraction. That's going to happen sometime. There's no way around getting fractional asymptotes either. So a lot of that different stuff can happen. Nothing wrong with it, but the big thing is to understand how to get it by hand, because Desmos a lot of times will not show you what they are. It'll just graph the function where it goes, and you won't even be able to tell where the asymptote is. And if you try to guess where it is, you're going to most of the time get it wrong, if it's a fraction especially. And then the whole is the part that did cancel out with the numerator, and that's the x plus 5. When I set x plus 5 equal to 0, I get x equals -5, and that becomes my whole for this graph. So again, we'll talk about how to graph this on a coordinate system later, but for now, just get comfortable with finding the horizontal asymptotes, vertical asymptotes, and holes, and then we'll do the next step in another section.